So let me share this once again. Now talking about that particular example which we have seen, right? So initially we were having image. So what I'm saying is just assume that suppose the input initially we have given it was a dog image. Just assume that, right? But the output we got is cat. Final output which we got is cat. Okay. So expected output was a dog and we got cat here. So in this case, what is going to happen is, so this was the scenario. I was having I1, I was having I2. These are the two neurons we have, and hidden layer was there like this. Okay, and then we were having output layer, and they are internally connected like this. So this one is connected to all of them, and the second one is also connected to all of them. Right. So in this case, we have seen that we got the output as 1, 0, 0. This first point we are seeing, and as they are internally connected, I will join these points also. Now, my point is that let's suppose you passed the input as dog and you got cat. Expected output was dog, but you got cat. So what to happen in that case? So in that case, what we will do is there are two processes that will be involved in this case if you are getting a wrong output. So the first process we are going to talk about is back propagation. So back propagation is going to help you if you are not getting the correct output, or if it is going to help you to decrease the error. And another method is called as gradient descent optimizer. This is what we want to see if the scenario is that you are not getting the correct output. So gradient descent optimizer. Okay. Now, what these two things will do? Let me talk about this particular point first. What is gradient descent optimizer? Okay, this will be your output either 0 or 1. So we have already seen that 0 is cat, no one is dog. Right? So here, what is this gradient descent optimizer? Let me talk about that. So gradient descent optimizer is basically an optimization technique which is going to give your output as an optimal output. So it's an optimization technique which changes the value of weight, right? So if you people remember, we were having some weights in the previous figure. We assigned some weights to all those edges, right? So if you remember, it was something like W1 here, right? W1 was coming, it was W2, and similarly for, so this was X, this was Y, and this was Z, right? So in this case, I named it as WA, and this one is WB, and this one is WI, and this one is WJ. So similarly, there will be weights for output layer also, right? So what will happen in this case is we will be having the weights here W11 for example, W22 and W23. Suppose W33 for example, right? Now I hope now you know the meaning of the weight. So finally here is this is our predicted output. So in if you are not getting the correct output, if you pass input as dog and if you are getting cat, that is wrong output. So this GDO, gradient descent optimizer, as I told you that it's a optimization algorithm which changes the value of weight, which is going to change the value of all these weights. Whatever we have, all these weights, whatever total how many? This 6 plus 3 is 3. Total 9 weights we have in this particular figure if you check, right? In this model if you check, total 9 weights we have. So gradient descent optimizer is going to change the value of the weights to correct the error, or we can say to reduce the error. So what basically it will do is it will go back to the previous layer, right? If it is getting the output as cat, which is the wrong output, it will go to the previous layer, that is hidden layer in this case, and it will say that okay, I got the wrong output, please correct it. Now, what these layers will do, what this layer will do, what this hidden layer will do in our case. Now, this previous layer in turn will say to the first layer that we got the wrong output, please correct it, right? So what the first layer, that is what this layer will do. So it will change the value of weight to some other value. So it is going to change the value of all these weights, whatever we have initialized randomly, right? It is going to change the value of all those weights. So that means it is going to backside. So this particular layer is going to tell this particular layer that okay, output is wrong, do something. This particular layer is going to tell this particular layer that okay, output is wrong, do something. So this input layer is going to change the weights which we initialized as random weights. So that means all the nine weights, if you just count, these are total nine weights. So all the nine weights, nine values of weights that we are using here will be changed, right? Those values will be changed, and the same process will be applied again. Whatever we have seen till now, I1 W1 plus I2 W2, right? Plus bias. That same process will be applied with the new weights, right? The complete same process will be applied once again, whatever we have seen till now, right? And suppose after applying the same process again, again here we got the output as cat. That means the wrong output, right? The second time also we got the wrong output. Suppose so, weights will be changed once more. So once again it will go to the previous layer and it will say that okay, the output is wrong. This layer in turn will go to this particular layer and say the output is wrong. Do something, right? So the weights will go on changing till we get the highest accuracy. Our purpose is what? Our purpose is to get the highest accuracy. Now, what do you mean by this? That means highest accuracy, or I can say least amount of error, right? So that process is going to repeat again and again, right? And the weight where we are getting the highest, so wherever at whatever point we are getting the highest accuracy, that will be your final weight. So it will go on changing the weights again and again till you get the highest accuracy. And the point will come where you have a highest accuracy or the least amount of error, least amount of error. So those weights are going to be the final weight. Try to understand. Okay, initially I said that initially the weights are going to be random, but later on they will be changed again and again, and they will be go on changing. They will go on changing unless and until we achieve the highest accuracy. So we calculate the new weight using something which is called as back propagation, right? So we calculate the new weight using back propagation. There is a formula for back propagation. We will talk about that. Okay, I will just talk about that after this particular point. So see, going back to the layer and changing to new weight is called as back propagation. Going back to the layer, previous layer, and changing the weight. This process is called as back propagation, right? And I was talking about gradient descent. And calculate what is gradient descent? Calculating the new weight is gradient descent optimizer, right? So I will try to concentrate on this particular term more. So the formula, let's first of all see the formula for back propagation. So how it actually calculates the new weight. Let me try to talk about that particular formula. The formula is like this: new weight W new is equal to old weight, whatever the older weights we were having in our case, plus alpha into dy by dx. Now what are these things? So new W new is nothing but the new weight. W old is nothing but the old weight, right? So this is new weight, this is old weight. What is this alpha? This alpha is actually called as learning rate. This is called as learning rate. What is that? We will see. There is a constant value for that. Okay. Learning rate means what? Learning rate means at what rate you are changing the value of weight. And that is called as alpha, or it is called as learning rate. Right? And what is this? Dy by dx. This is actually the derivative of activation function. This particular term is actually the derivative of activation function. And in our case, the activation function is sigmoid function, right? That's why I asked you about the derivative of sigmoid function. So try to understand this particular term. W nu is equal to W old plus alpha into dy by dx. This is called as the equation of back propagation, right? This is what we are going to make use of in case of back propagation and gradient descent optimizer. How? I will see. I will show you that. Okay. And based on the value of learning rate, based on the value of alpha, we pass a very small value, and generally we pass error value actually. Again, it's a very small value. So basically, after calculating the new weight, what we do is we add that particular thing, that is alpha into dy by dx. We add that particular thing, which is our gradient descent optimizer. We add that particular thing to the new weight. This is what you can see from this particular formula. Right now, let me just clear these things. Let me write down the formula once again. So I was talking about this particular formula to calculate new weights. W new is equal to W old plus alpha into dy by dx. So what is this alpha? Alpha is a learning rate. That is at what rate you are changing the value of the weight. That is called as alpha. And dy by dx is nothing but derivative of activation function. In our case, the activation function is sigmoid we are trying to achieve. Okay. So once this is done, once you have alpha value, once we have derivative of activation function, so in this case we are having sigmoid function. So we will take the derivative of sigmoid function, whatever the value we get for this particular thing, dy by dx, we add that to old weight. Okay, that is W old, and that is what is going to give us the W new, that is nothing but new weight. So this complete process is known as back propagation. Try to understand, right? Finding out, going to back and calculating all these things, this complete process is known as back propagation. And descent gradient optimizer actually make use of this particular thing. This is our descent gradient optimizer. Okay, so now how to find out that the model is having error? How to find out that my model is having error? Let's try to talk about that particular thing. Suppose that I am getting desired output as 0. Let's suppose I am getting desired output as my desired output is a 0, and the predicted output which I am getting, okay, so desired output is 0, and that means the actual output, whatever we want is 0, and the output which I am getting with the model is 1. So what will be the error? 1 minus 0. The error is going to be 1, right? So because your actual output is not matching to the desired output, so the error is 1 in that case, which is an error in our case, and which is very huge error, we can say, right? So second case is if we are getting predicted output as 0, suppose, okay, and the actual output is also 0. So in this case, 0 minus 0, that means your error is also 0. That means in this case, there will be 0 error, and in this case, there will be some error. So we take the average of all these errors and we see that how much average we are getting. What is the average of all the errors? So if we are getting higher error, that means the model is not correct. We have to train it again and again, right? So if, for example, let me give a very simple example to understand the complete process regarding the back propagation and gradient descent optimizer. Let me just clear it just in 5 minutes. You'll be able to understand whatever I'm trying to talk about here. So if you want to understand both those things, back propagation and gradient descent optimizer, right? So let me just put a very simple example. Suppose uh, just suppose see, right now I am your instructor, right? So I am teaching something in this particular session. I am teaching to you and talking about some topic. So let's suppose that I am teaching some participant a particular concept, right? And I am teaching that particular thing every day. That particular concept I am repeating again and again every day. So in that case, as the same thing will be repeated many times, student or the participant will become more accurate, obviously, in that concept, right? He is going to get a lot of things in that concept because the same thing is being repeated again and again, day by day. So now every day at the end, once I teach that particular participant, at the end of the every day, what I will do is I am conducting some tests of that participant, maybe through Viva or maybe some other ways. For example, I will ask him, tell me the answer of this or tell me the answer of that. And suppose the participant gives the wrong answer, right? Let's suppose participant gives you the wrong answer. So what can I do? What can I do is maybe suppose I will take some strict action against that person so that he will think again, go back in mind and think again about whatever I have taught that particular person and then give me the answer or the output, right? So if suppose if second time also he gives wrong answer, I will repeat the same process. That is, I will take some strict action against that person. Like this, I will ask the question again and again. I will repeat that particular process again and again. And if that participant gives the correct answer, I will tell him that, okay, it's correct and that's nice. Right? That means again and again, if I am asking the question and he is giving the correct answer, that means he has been trained well. And if he has been giving he is giving wrong answer, suppose, that means he has not been trained well and he needs more training in that case, right? That is there is a need to teach him more, and then only he will start giving the correct answers. So that's a simple example to understand this whole thing, back propagation and gradient descent optimizer. The same thing actually we do in this case also, right? So, and that is the whole thing whatever we have discussed till now, the whole thing that is called as artificial neural network, right? Now here what we will do after this, with the help of whatever the theory we have seen till now, right? We will try to create a model for with the help of artificial neural network. So what type of problem statement we will discuss here is it's like a binary data I will take, and you can say a gate kind of a data. Suppose we have three inputs, right? So suppose we have three inputs and one output. This is what we have. And those inputs are like this. Let me just write down. This is our data. Suppose I have input like x1. This is the first input. Another input is x2, and another input is x3. Suppose these are the inputs, right? And we have some output called as y. Let's suppose y is our output. Okay, and let's try to understand what is this problem statement, because this is the thing which I am going to implement now, so that you will be able to understand all the steps whatever I have talked about till now. So let's suppose As I told you that there are three inputs, right? So these are our inputs, these are three inputs, and this is going to be our output. Y is going to be our output. Now, what type of inputs I have? Let's suppose I have the inputs like 0, 1, 0. Okay. Let's suppose I have 1, 0, 1. Maybe third sample will be 0, 0, 1, and last sample will be 1, 1, 0. This is the input we have. Okay, now corresponding to all these inputs, definitely as data will be with you, so you'll be given some output also. Let's suppose the output of first row is 0, second row is 1, this is what our target, third row is 0, and fourth row is 1. Let's see, it's not compulsory, right? We are just trying to take in the random data, so that I just want to tell you the concept of implementation of artificial neural network. So what we will do is we will write down a simple program for this one, and we will try to achieve this particular target with these inputs with the help of artificial neural network. Right? So let me. So we are going to need this particular data later on. So let me just try to take a screenshot of that, and let me go and clear it, and let me try to add it into a Word file so that it will be easy for us later on to refer the values. So these are the values. Okay, these are the values we have. Now, what we want is we want to create a simple neural network for this data, whatever I have shown here, right? Whatever the data you are able to see, whatever the problem statement I was trying to write down here. So we want to create a simple neural network for this data, and we want the output for those four samples, right? All those four samples, we want for all these four samples, 1, 2, 3, 4, we want the output like this, which is given, like given in Y. So whatever the output we will get, we will compare that output to this actual output. This is what our actual output is according to the given data, right? So our model, whatever it gives us, we are going to compare that to this particular actual output, and then we will see how much error we get, and that's what our problem statement is, which we will see through some coding, right? We will try to write down the code for this one, and we will see whether we are getting the desired output or not. So whatever we have discussed till now, we will write the code for each and every step and try to understand simple neural network. Right. So what I will do is I will just clear it, and I will try to go to Jupyter in the browser. So here this is my working directory. What I will do, I will try to open a new notebook. Okay. See, anyway, we are going to need all that data, whatever I have shown you just now. So here obviously, as we want to work with this particular example, so you can see 0 1 0 1 0 1 0 0 1 and 1 1 0. This is my input, and 0 1 0 1 is my output. So what I will do is we are going to create the same data. So obviously I am going to need numpy package first, because this we are going to need for creating the random walk. So first example I will show it step by step. All the remaining examples which I talked in agenda, I will be directly showing you the execution of those things, because now after this, once you understand all these steps, you will be able to relate all these things to those code, whatever I'll be sharing with you people. You will be able to relate all those things with the remaining examples whatever I'll be showing you. So let me just run it. Shift enter. So here we are doing what? Here we are just trying to import number. And let me tell you, I am in this environment, tf underscore ypm, which is the TensorFlow environment which I created in the morning, if you people remember. Right. Once that is done, after importing NumPy, what I will do is I will create my input data. So inputs is equal to, now just try to see this particular thing. What are the inputs we have? So 0 1 0, 1 0 1, 0 0 1, and 1 1 0. Okay, same data I'm just trying to create here. So how to create the array in NumPy? So the command is np.array. Right. So go here and try to create the array with the help of NumPy. So in the first case, what we want is we want 0 1 0. This is what our first cell is, first observation is, right? We have four samples. Second sample is 1 comma 0 comma 1. According to that data only I am giving. So see, we need something for reference. That's why I'm trying to actually create the same data, because we people also will be in a position to relate whether we are getting the correct output or not, right? And the last sample is 1 comma 1 comma 0. Now let us check. See, this one is 0 1 0 1 0 1 0 0 1 1 1 0. Let me go here. You can check it. 0 1 0 1 0 1 0 0 1 and 1 1 0. Let me know if anything is wrong. I think it is right. 0 1 0 1 0 1 0 0 0 1 0 1 0 1 0 0 1 and 1 1 0. So see, what I have done is whatever the rows you are able to see in this particular example, I have just tried to create an array of that, right? This one. Now after this, so this is what our input is. These are our inputs. These are our input samples. So what I will do is I will just go and run it. Now my inputs are this. You are able to see we have created an array here. Okay, this is what our input is. Same thing, whatever I have shown there, right? Same thing, 0 1 0 1 0 1 0 0 1 and 1 1 0. After that, as in this example, you have seen that y is our output. What is the output? 0 1 0 1. This is our desired output. In this y column, in this y feature, you are able to see that 0 1 0 1 is our desired output. So what I will do is I will try to create one more array with the help of numpy like this. Outputs is equal to again np dot array I will show, and I will try to create the array. Right. So what was that? 0 1 0 1. So it is 0, comma, it is 1, comma, it is 0, and comma, it is 1. This is what our desired output is. And let me check whether square bracket should be right, because it should be right because the array is a two-dimensional array, right? It's a matrix. Now I will go shift enter. Now you'll be able to see this is my output, right? So we have input data and output data ready. See, those people who joined just now, just understand we are trying to create artificial neural network, right? So after this, what we will do is we are going to apply the formula, right, which we have already seen. So we have inputs, but we do not have weights, right? As I told you that initially we are going to assign the random weights. So we will assign random weights here also. For that, what I will do, I will just try to use numpy dot random, np dot random. I hope you people are aware about this particular method, which is available in case of numpy package. So np dot random, and I am going to create an array of shape 3 comma 1, right? Why 3 comma 1 again? Because 3 comma 1 matrix we are going to create here because we have 3 inputs. So we get the weights of I1, I2 and I3. That's why I am creating the array of 3 comma 1. Just try to understand that one also. And here I will assign it to some variable called as weights. Let me run it. Shift enter. If I go and if I try to show you the weights, you will see the weights are like this. Because these are random. Try to understand. Numpy np.random, it is going to create the random value. Okay, so np.random.random has given me random values. After that, what? Now, if you people remember the formula which we have talked about, formula for artificial neural network, what was that? The formula was like this: summation I equal to, it was 0 to n, right? Summation I equal to 0 to n I this one into wi plus bias was there, right? This was the formula for artificial neural network which we should refer, right? These are weights, these are inputs, and this is the bias. Now, according to the same formula, what I am going to do is I am going to calculate all the sums. So, what is this? What is this star? That star is nothing but a dot product. Whatever you are able to see here, what is this? This is nothing but dot product, and we can calculate the dot product with the help of numpy. So, what I will do is I will take a variable called as sum and np dot dot. This is the method which is available in case of numpy, with the help of which you can go and you can actually perform dot operations, right? Dot product. So what dot product of what? I, that is inputs, comma what? I into wi, that is what? That is weights. So weights, right? And plus you need to add bias also, right? You need to add bias. So if you people remember bias, you can take anything, very small value, right? Any small value you can take. Here I will take the bias as 0.02 and let me run it. Shift enter. Now the sum is like this. Now how we got the value of this sum? Just by performing the dot operation. It's just like a matrix multiplication. You might be knowing about that, right? This is the value of sum. Now what the next step is? Next step is to apply the sigmoid function, right? If you people remember, sigmoid function 1 upon 1 plus e raised to power minus x is the equation of sigmoid function, right? So I will just write down the equation of sigmoid function for your reference. The equation of sigmoid function is sigmoid is equal to 1 upon 1 plus e raised to power minus x. In our case, the activation function which we are using is sigmoid. That's why I'm talking about sigmoid. Otherwise, there are other ways also. There are other different many different sigmoid functions which are available. So what I will do is I will just go and I will create a function called as activation function, right? So in this case, it will be according to sigmoid function definition. So define activation of some variable x right? I hope you know how to define a function in case of Python. This is how we write down a function in Python. Return, what it is going to return? It is going to return 1 upon 1 plus e raised to power minus x. How I can write it down? So 1 divided by, in brackets, what I can write down is 1 plus, how you take exponentiation with the help of numpy. So np dot, we have something called as exponentiation, right? So np dot exp of what? Exp of minus x you need to take, because just look at the formula of sigmoid function, which is our activation function in this case, which is 1 upon 1 plus e raised to power minus x. And that's why I have taken this particular thing as return. It is going to return, this activation function is going to return this particular thing if you pass the value of x as input to it. Let me run it. Now the definition of sigmoid function is correct. That means what? That means what's going to happen because of this particular activation function. That means here in the x, here whatever the value will pass, it will apply the sigmoid function to that particular value. And basically, it will convert that sigmoid function in between 0 to 1. Because we know how sigmoid function works. Sigmoid function always lies between 0 and 1, right? And what is actually x here? So x is going to be the value of the sum. The x here is going to be sum in this case, right? So after that, once we have defined the sigmoid function, right, which is our activation function, now we will try to calculate the output. So what I will do is I will apply activation function to the sum, because sum is going to be our x, and I will assign this particular value to some variable, that is y prediction. This is the predicted output which our model is going to give us, right? And I will just run it. And if I go and if I try to see what is the predicted output I got here, y prediction, what I got here, if I go and if I try to see, let me show you what it is going to show you as output. So see, what is the output? 0 0.6, 0 0.81, 0 0.64, 0 0.84. Now let me just tell you what I told you in the morning is that the function which we are going to make use of is nothing but a sigmoid function which is between 0 and 1, this is 0 and 0, 1. It makes use of something called as threshold value. What's going to happen is each output will be compared with 0 0.5, 0 0.5. So 0 0.68, is it greater than 0 0.5? Yes, it is greater than 0 0.5. That means output is 1. 0.81, is it greater than 0.5? Yes, it is greater than 0.5. That means output is 1. Here also 1. Here also 1. That means our final output is 1, 1, 1, 1. But what we want actually, what we want, if I go and if I try to show you the same problem here, what we want is the final output which we want here is 0, 1, 0, 1. What we got is 1, 1, 1, 1. That means we are not getting the correct output. That means we need to train our model once again, right? Here also, if I go and if I try to show you what is our expected output, so you can check our expected output is 0, 1, 0, 1. But what we got according to the sigmoid function, we got 1, 1, 1, 1. I hope you people are able to understand this particular point, because here in this case we are going to compare each and everything with threshold value, that is 0 0.5. And each of these values is actually greater than 0 0.5, and that means our final output is going to be 1, 1, 1, 1. But we do not want 1, 1, 1, 1. We want 0, 1, 0. That there comes the back propagation and the gradient descent optimizer. Now I will show you how to make use of that and how to get the desired output. So this value, whatever you are able to see, right, all these values. So this value, the value which we got as a prediction in the first step, this is the value which we got as a prediction in the first step only. That's why it is not correct, right? So here we are just taking two layers again, input layer and output layer only. No hidden layer is taken here, right? So basically we use hidden layer when we have complex problems or for complex problem statements. But here in this case we have a very simple problem statement, right? So that's why in the first attempt only we did not get the desired output. We got something wrong, which is 1, 1, 1, 1, right? But our desired output is something different, and which we are expecting, what it was like 0, 1, 0, 1, right? So what I will do is I will try to show you the error here. Suppose let me calculate the error. Now what will be the error? I told you error will be actual output minus predicted output, right? Everyone knows this. So in this case you will see that how we are getting the error. So see, error is minus 0 0.68, 0 0.1, 0, minus 0 0.6, 0 0.15, which is actually very high. So this error should be near to 0 actually. Okay, then only we will get the desired output or the good result. But here it is not. It is not near to 0, and it's a very high error. Why this is a very high error? Why are we getting this high error? Because we have not trained the model. We haven't trained the model here. Okay, so it's simply like, for example, if you talk about the previous example which I have discussed, so it's simply like today I have taught you something, right? Some concept. I conducted the exam or test. So obviously, first time only, one might not be able to give the correct answer, and definitely there will be a chance of a mistake. This is what is going to happen, and this is what happens with humans, right? That's a natural human tendency. We might need to repeat the same thing again and again to have a good hands-on or to have a good practice of that, to understand that particular thing deeply. We need to repeat that particular thing again and again. The same thing has happened here. We have just got the output widespread in the first attempt only, right? But what we will do, so in that case, I should train the person more. That means we need to apply gradient descent optimizer and the back propagation. So that error should be reduced, right? So if you remember, what was gradient descent optimizer? It was something like, just now we have seen the equation, it was something like alpha into dy by dx. Okay, so what is dy by dx? This dy by dx is actually the derivative of activation function. In our case, the activation function is 1 upon 1 plus e raised to power minus x, which is sigmoid function, right? So and one more reason of getting this particular error is that we haven't applied these two techniques, and that's why we actually got the higher error. So let's try to do that now. Let's try to apply back propagation and gradient descent optimizer, right? So what I will do is, here I will try to write down one more function for gradient descent optimizer. So define gradient. Suppose the name of the function I will give it as gradient. So define gradient. It is going to take two inputs. One is the input value and another one is the error value. Whatever the error which we got, we need to decrease that particular error. So it is going to take error value. So input and error, these are the two parameters which it is going to need. What it is going to return is, it is going to return alpha into dy by dx. This one, it is going to return alpha into dy by dx. Alpha I can understand. Alpha I can take it as error, right? So here I can take it as some value e, suppose. It's a very small value. Into alpha into what is dy by dx? I told you dy by dx is the derivative of sigmoid function. Now the question is, what is the derivative of 1 upon 1 plus e raised to power minus x? What is the derivative of d by dx of this particular thing term? Because this is our sigmoid function, right? So for this, one should have a knowledge about basic things of derivative. If you do not have a knowledge about derivative, don't worry. Each and everything I have explained in one of the documents, right? So let me show you that particular document. See how to calculate the derivative of sigmoid function. So you will get this particular document, and in this case you will be able to see that we have calculated the derivative of this 1 upon 1 plus e raised to power minus x. So I am not going to go into the detail of all those things because we want to implement other things also. So I will directly go and I will directly just go through all the steps. It's a very simple explanation, and I will directly show you the output of this particular derivative. This is the output. The derivative of that is this sigma of x into 1 minus sigma of x. So you just need to replace the sigma with whatever the term you are actually using in your equation. For example, this is what we got. So they have just replaced this 1 upon 1 plus e raised to power minus x with sigma x. So actually this is the derivative. So 1 upon 1 plus e raised to power minus x into 1 minus 1 upon 1 plus e raised to power minus x. This is the derivative of the sigmoid function. How it is achieved? Everything is given in this document. If you want to see it graphically, so the red color graph, this dotted color, red color is actually showing you the graph for derivative, and this blue color is showing you the graph for the original sigmoid function. Okay, that will be enough. I think you people will be under you will be in a position to understand once you refer that particular document. Just 3 to 4 pages only. Okay, so what I will do is, according to that derivative, I will write down the derivative here. E into, so what I will do is, I will use a parenthesis here. So x into e into x into 1 minus x. So from where I am getting all these things, try to understand. This thing is just a derivative of sigmoid function. That's it, nothing else. I am just following this particular equation. Okay, it's not any magic kind of a thing. Just try to understand this one. That's why I have written this particular function. Okay, so e into x into 1 minus x. Try to give the brackets correctly and let me run. Okay, so that was my gradient descent function which I have written, which is going to accept the input and the error. After that, what? Now we will apply this particular gradient descent function to our data. How? Let me show you. See what we have is, we have already calculated a sum. So how we calculated a sum? Let me copy this particular line. sum is equal to np dot dot. So I will again write down the sum here. So sum is equal to np dot inputs inputs comma weights plus 0.02. This is the sum, right? This is what we got. After that, what we are going to do is I am going to calculate prediction. So again, I am just going to take that particular step where I have calculated the prediction. So this is the step. I will just copy it, Control A, Control C. I will go here and I will copy that. Even if you run this step by step, also no problem. Okay. So, but we have already written that. That's why I'm just trying to copy it. And at the end, we are going to calculate the error. So error is equal to output minus the output, original output minus the predicted output. That's what the error is. Okay. Now, if I apply this particular step and if I try to calculate the error once again, you will see that I am going to get the same error. There will be no change. There will be no change. Same 1 1 1 1. Right. I am going to get the same thing. Now, what I will do is, as we need to apply back propagation and gradient descent optimizer, so we need to calculate the change in the weight. So what I will do is I will use one variable that is change underscore weights. Okay, so change underscore weights is equal to, now I will apply gradient descent. So to this gradient descent, we will be passing two arguments. One is the predicted y, and another thing is the error which we got. Right? So y prediction and error. These two things I am going to pass. So what is this change weight actually? What is this change weight? Why are we doing it? That means how much change we need to do in weights. How much change we need to do in weights. That's what it is going to calculate. That's what gradient descent is going to calculate. And gradient descent, just now I showed you, it is going to make use of sigma function. So let me just shift enter here. Okay. Now name key is not defined. Let me check where is the error. Okay. It is saying that name key is not defined. This key, this particular thing, I will have to check. It should have been, let me see, it should have been key here. So that means that, right? So let me define this particular. So it's a simple mistake actually, variable. I should have written it as key. Let me run this particular thing once again. So I have run that. Now let me go and try to run this particular function once again. So run it. Now change in the weights, I am able to see like this. This is the change in the weight. First time the weight should be changed like this, right? Now what we will do is we will apply back propagation. So we will calculate new weight is equal to old weight plus that particular thing, dot product, right? So according to the formula whatever we have seen to calculate the new weight, I am going to make use of that particular formula. So here weights is equal to older weight, that is again weight. So new weight is equal to older weight plus np dot of what we need, dot product of inputs. Okay, dot product of inputs and change in the weights, change weights. Try to understand dot product of inputs and change weights. But if I show you the shape of inputs and shape of change weights, they are not same. That means you might be knowing. Let me just add one more say here. What am I trying to talk about here is, if you try to see the shape of inputs, if you try to see the shape of inputs, it is 4 by 3. Okay, and if you try to see the shape of this particular thing, change underscore weight, let me add one more say here. If you try to see the shape of change underscore weight dot shape, if I go here, it is 4 by 1. Now this is 4 3 and this is 4 1, and you might be knowing a basic rule of a matrix that to do a dot product of two matrices, number of columns in the first matrix should be equal to number of rows in the second matrix, and which is not the case here. So what I will do is I will just try to take the transpose of inputs so that it will be 3 comma 4, and then this and this is going to remain same. So how to calculate the transpose? You just need to go here and you just need to apply dot t. That's it. So try to understand why I have done it. I had done it because the multiplication was not possible. That's why inputs dot t, this is going to give me the final weight. So weights is equal to weights plus np dot dot and take the transpose of inputs, so and the change weights. Let me go and calculate the weights. Now we calculated the weight. Okay, now let me check. Okay, error we have already checked actually. We obviously we will get the same error, right? But if we execute this code again, right, whatever we have seen till now, so starting from calculating the sum, so if I go and if I try to show you all these lines, so if I execute this particular code once again, that means we are going to apply what? We are going to apply back propagation. So sum this particular line, I am going to calculate the y prediction, I am going to calculate the error, and one more thing I need to add here is change weight, right? Change weight also I need to calculate again and again. This is what gradient descent does, and gradient descent and back propagation does. I am going to calculate. So those people who understood the theory, they will be able to make some sense out of this particular thing for sure, right? So change weight we are going to calculate once again, and after that, once we calculate the change weight, we are going to calculate the weights again. So weights are going to change till the point. Till what point? Till we get the highest accuracy or the lowest error, right? And finally, I am going to calculate error. So this is our video. Okay. Finally, we are going to calculate the error. Now, what I said is, if we execute these particular steps again one more time, my error will be reduced. Maybe I might not get the required answer, but my error will be reduced. Let me run it once again, and let me show you. See, this is the error. As compared to the previous thing, now if you check, the error is reduced. So if you go here, see, error was 68, now the error is 66. Error was 18, okay, here it is increased. Here it is 64, here it is decreased. Here it is 0.5, here it is 1.6. So somewhat decreased, right? But this is not what we want. We want the final output as 0101. So what I will do is, instead of repeating these steps only one time, what if we repeat these steps 1000 number of times? That means our error will be reduced more, right? That is what back propagation and gradient descent optimizer is. What I will do is, I will write on a simple formula. For example, some variable I or I in range function. I hope you are aware about that. So I am going to repeat all these steps 1000 times so that my error will be reduced very much. And let me take care for the indentation also, because here we are using uh, for loop, right? And finally, I am going to print the error. Now let me show you. And before this, see, before this, if I go and if I try to show you y prediction value, let me insert a cell above here and let me show you y prediction value. Okay, y prediction value, if I show, see, it is greater than 0.5, that means 1, greater than 0.5, 1, greater than 0.5, 1, greater than 0.5, 1. That means I'm still getting the output as 1, 1, 1, 1. But what we want the output as 0, 1, 0. You can check in y. We want the output as 0, 1, 0. Right. Now what I will do is, I will run this particular code, all these things 1000 times, and then I will try to show you error as well as the prediction. Let me run. Now see the error. Minus 0.033, minus 0.02, minus 0.033, minus 0.02. Now if you see, this error is very much reduced as compared to this error. Just try to understand, this particular error is very much less. Now if I go and if I try to show you y prediction value after this particular point, we should get near output, right? Let me check y prediction and run it. Now see, as we are using sigmoid function, so you know that sigmoid function makes use of threshold value. So just check 0.03, it is less than 0.5, that means the answer is 0. 0.97, it is greater than 0.5, that means the answer is 1. 0.03, it is less than 0.5, that means the answer is 0. 0.97, it is greater than 0.5, that means the answer is 1. That means we got the output as 0101, and that's what we wanted. If you go and if you try to see in the problem statement which I shown earlier, see 0101, and we also got 0101. That means we got the correct output. So it's possible with the help of back propagation and gradient descent. That is the implementation of artificial neural network, right? So this is what artificial neural network is. So what I will do is, I can go here and I can save this particular file as, I can name it as simple neural network. Okay, simple neural network. Just I will just save it. So maybe I will be sharing this particular file with all of you. Okay. So this is what your artificial or simple neural network is. Now we got the desired outcome. All the steps, whatever we have seen earlier. So this is a very simple artificial neural network which we try to execute. So here if I go and if I try to execute this particular thing once again, I will again get very less error. Right? And if you see the output now is the prediction output now is the output which we want. That means our predicted output is 0101 and this is what we were expecting. Right? So in this case, as I told you that we are using input layer and output layer, but if you want to add one more layer you need to apply same thing to that next layer also, right? If you want to go and if you want to make use of some layers, definitely you can go and you can make use of those layers also as per your problem set, right? So this is what the problem set, this is what our solution is, this is what our artificial neural network is, right? Simple artificial neural network. Okay, now after this one, so let's try to go and try to implement one more example which is related to uh, what was that image data. So till now what we have seen is we have implemented simple neural network in Python, right? And now we will try to implement one more architecture which is related to artificial neural network only. One more example we will see. Okay, not image data actually. Before that, I will go and I will try to show you. I will not write down the code now. So yeah, this one. So this is the example of identifying breast cancer, whether the particular person is affected by breast cancer or not. And see, don't worry about the data set. I am actually taking the data set from this particular link. What I will do for this one is, I will be sharing one document with you, and which will be this text document, this one. So whatever the data set I have used in these 3 to 4 hours, right? Whatever I have shown you in the sessions, the links of all the data sets are given in this text file. So I'll be providing this particular text file to you, and you will be able to download the data set which you require for the assignment of this particular thing, breast cancer example. You will be getting X-ray data set for COVID-19, which I have shown you in the morning. So don't worry about those data sets also. I will be sharing the links. Right. Now, next thing is what? As I told you, we will see another problem which will be implementation of artificial neural network. First, from a simple neural network, here we will implement artificial neural network, which is going to create a model which will help you to identify whether a person is affected by breast cancer or not. So here I will just run this import numpy as import numpy as pandas, import pandas as PD here, particular thing. Okay. Now, or otherwise, I will go and I will try to show this so that let me run this one. See how are we implementing the artificial neural network for that particular data set. I will show you how we are actually fetching the data set. So here we have imported numpy. Here I am importing pandas package because we need to fetch the data from some external link. That link is this one. Okay, this one. So path is equal to. So once you go to this particular link, let me just go and try to select it. So suppose if I go and if I try to show this particular thing, Control C and open new tab and go check it, you will be able to see this kind of a data. If you want to see that, I will just paste the link in the chat box. Just go and you can even download the link for the data set. I have sent in the chat box. There we are. So that's the data set. This is the data set I am going to make use of. So you can see it's like a CSV file. Okay, comma separated value. What I'm doing is I'm just trying to get that particular data set get imported in Python. That's why I'm just assigning it to some variable pandas package. That's it. Go here, and if you want to see first few records of that, so suppose if I want to show how many records are like this. So okay, sorry, I did not import it. I just assigned this particular link to path. So this is what my path. I just assigned this particular path to some this particular link to some variable from where I am going to print the data. Now what we will do is we will read that CSV file. So pandas.read underscore CSV is the command to fetch the data from a CSV file. It's a basic pandas command. Now this is my data, right? So it is just importing everything from that CSV file. into this variable. Now if I go and if I try to show you what is the shape of that, shape, data dot shape. Now see, there are 569 rows and 32 columns in that data set, right? So if I want to show you first few data set, first 5 data sets, first 5 observations from that data set, I can show it. Sorry, it should be data dot head. My variable name is this. Go here and run it. You will be able to see first 5 records because head command by default shows you first 5 records. Now you can see which are the types of columns here: ID, diagnosis, radius mean, texture mean, perimeter mean, area mean, and so on. All these are the features in this particular data set, with the help of which we need to create artificial neural network which will help you to detect whether a person is affected by breast cancer or not. Now, out of all these columns, so we don't worry about the meaning of all those columns right now, okay, because again it will take much time. So try to understand this is what our target column is. In this case, this is what our target column is. In this case, what are the values? There are two different values. One is M and another one is B. So M actually stands for malignant. Malignant means that person is affected by breast cancer. And another one is B. So B actually stands for benign. Benign means that person is not affected by breast cancer. Or in this case, I can say this person is positive, this person is negative. Right? So this is what our target column is. See, there are more than 500 rows. Okay, as I use head command, that's why we are not able to show all these things. You might be knowing that. So here, what we will do is now we will try to see some more information about the data set. So data.head we have done. Now let me show you which are the unique values in that particular target column. So I told you that we have M and B as the unique values in our target column. Our target column is diagnosis. M stands for malignant and B stands for benign. Malignant means that person is affected by breast cancer. Benign means that person is not affected by breast cancer. Okay. Now, once we have seen the unique values, now let me go and let me show you the count of the values. All these things are necessary to understand the data. So you can see there are 212 people who are affected by breast cancer in our data set. We have the number of people who are affected by breast cancer. And there are 357 people who are not affected, who are benign. They are not affected by breast cancer. Right? Now, these are the number of count of the people who are positive and who are negative. Seaborn package you might be knowing. Seaborn is a package which you can make use of to plot different plots, different diagrams you can say for visualization. Seaborn is again one of the most basic package which you can make use of. What we will do is we will try to plot the count plot. Count plot is going to give me the same thing whatever we have seen, the count of all those patients here, the malignant and benign. So see, you can check there are more people who are negative, which is shown with orange color, and there are less number of people who are positive, that is shown with blue color, that is M. So malignant and benign, these are the two categories of people which we have in our diagnosis column. Right now, this is the command you might be knowing. This is the command to check how many number of null values are there. So if I go and if I try to run this, you'll be able to see that I am getting true and false. So I just want to calculate all the values in this particular column, right? Or how many are null in every row. In every row, I want to check how many are null and how many are not null. So what I will do is I will just go here and I will try to take the sum of all the true and false, right? What it will show is it is going to show me everything, because everything is false in our case. False plus false is false. True plus true is 2. True in is 1 and false is 0. So everything is false. That means there is no any value, no missing value in this data set. That means we don't have to take care about that one. Okay. If there is a missing value, you know what to do. We need to take care for the missing values. We need to do something called as imputation, replacing the NA or missing values with some another value like mean or median or both, sometimes in case of categorical data. After that, you might have seen some machine learning models. In machine learning models, you people might have divided the data into input and output. So what is this? This is a simple indexing we are doing. What are we doing here? Data.iloc. ILOC means what? ILOC means index location. That means what are we doing here is we are trying to take all the rows. This particular column means what? All rows. And which column? The column starting from second column. That means if I go and if I try to show you the original data which start from second index, so see ID is the zeroth index, diagnosis is the first index, and radius mean is the second index. That means starting from the second index, get everything into X, and X is going to be what? X is going to be your input variable. That means accept the output variable, get everything into X variable. So that is going to be our input, and Y is going to be your output. What is this? All rows and the column which are index 1. That means diagnosis column. That means our output column. So here what we have done, we just divided our data into input and output. That's it. Let me show you. This is your X. This is how it looks like. Okay, this is how it looks like, and this is what our Y. This is it looks like, malignant and benign. Right? Y is our target column. Once we divided our data into input and output, now let me do the encoding of the data. Label encoding. What is label encoding? Label encoding is going to help you to convert your data into numbers. In our target column, if you see that our data is in categorical format, our data is in text format. It is not a numerical format. But you might be knowing that for almost all the machine learning and deep learning algorithms, the basic thing is that the data should always be in the form of numbers. That's why I'm going to do label encoding here, right? So from sklearn preprocessing, I'm just trying to import something called as label encoder, which is going to convert this B and M into 0 and 1. Right? Let's see how it actually converts. So I will call the label encoder like this. I will create the object of that named as LE. So LE is equal to label encoder. I am just calling that particular method label encoder, and I am going to apply that particular label encoder method onto my variable Y, which is my output variable. So Y is equal to like this. If you go and if you check Y now, it will not be M and B, it will be 0 and 1. So you can see what label encoder has done is it has converted M value. Wherever there is M, it converted M to 1 and it converted B to 0. That is what label encoding actually does. Why we are done it? Because that's the requirement of the algorithm, right? Without numerical data, we cannot move forward. So that's what we actually achieve. Now, as always, what we do is we try to divide our data into training and testing. Again, you might be knowing generally we divide 70 and 30 or 80 and 20. So in this case, what are we doing is we will try to divide our data maybe 30, 70, 80, 20 or 75, 25 or 85, 15. It depends. It depends on the data set or the problem statement. So here you can check. I have called that particular method train test split, and I am going to divide my data into training and testing. So you can check it. X train X test, Y train Y test, train test split, X Y, and test size is 0.15. That means 15% of the data is test data. That means 85% of the data is training data. I am going to make use of for training a model in this case. Right? And then we are actually trying to take care for one more thing, that is called as feature scaling. What is feature scaling? Feature scaling is going to make sure that each and every feature should be having the equal weightage, equal importance. So what it does is it actually tries to bring all the values to the same level, and we achieve feature scaling with the help of standard scaler. Right? Many people call it as standardization also. So here I am just importing standard scaler and I am calling that particular method which is called as standard scaler. The object I am creating is SC here. I am just running it. I am just calling that particular method, and now I am applying the standard scaler method on my training data, which is nothing but X train. So I am going to apply it on training. Maybe you can apply on other data also. So this is my scaled train data. What do you mean by this? It means it is going to bring the values of all the columns to the same level. That is same priority for each and every feature, right? So that our model will not be overfitted. So we just try to scale the train data. Here we are trying to scale the test data also. The same way we have scaled our train data. Here we are trying to scale the test data also. So after scaling, now we will go and we will try to create the model. So first of all, what we will do is we will try to create a sequential model with the help of C. In my case now I am able to run this tf.keras.models.sequential. Why am I able to run this particular command in my case? Because I am already in such a environment where I have TensorFlow. So that's why this particular command in the morning only I shown that tf import TensorFlow is going to work in my case, because I am already using an environment in which I have TensorFlow installed. So see, it should run in my case. Import TensorFlow STF. It should run in my case. It might not run in your case because you need to do what? You need to make sure that you should be in such an environment where you have TensorFlow working. right? So in my case, I already installed it. Let's see. It should not give me error here, any input error. If I go and if I try to import it, so see, it has not shown me any error. It has successfully imported TensorFlow as TF in my case. You just need to make sure that you create the environment for TensorFlow and you should be able to import that successfully. And see, try to understand. Many people, they are many times they are confused. I have seen they say that you need to install Keras separately. That's not the case. If you talk about TensorFlow 2.0.4, Keras is inbuilt in that. If you install TensorFlow, automatically you will be able to make use of Keras also, right? So don't worry about installing Keras. You will be able to make use of that once you install TensorFlow. So what I'm doing is to create the model, I'm creating the object called as model, and tf.keras.model.sequential. So I am creating a sequential model here, right, with the help of Keras. Now, whatever the theory part, whatever we have seen till now, that TensorFlow and Keras is going to take care for that. And now this is the code for input layer, hidden layer, and output layer. Now I am going to create all the layers. I hope now there should not be any problem to understand all these things. If you are clear with the concept which we have discussed in the morning, that's why I have just tried to give that much of time to that particular concept. Even if you people might be having some doubt, just go and revise all the things, whatever I just told you in the morning, and then again, once again, come to this particular code and try to make out of all these things. So you can see I'm just trying to create input layer, hidden layer, and output layer according to the problem statement. So here, once I created input layer, hidden layer, and output layer, now you can go and you can compile the model with the help of something called as binary cross entropy. So binary cross entropy is a loss method which is actually used in the case of binary class classification problems, where you have two classes, binary classes. And optimizer is nothing but what, see, I told you, gradient descent optimizer. So there are again a lot of options which can be used as optimizers. That metrics, which metrics I am using? Accuracy. That means you will be able to calculate the accuracy of this particular model with the help of some metrics after this. Right now, once I go here and I try to compile the model, so let me go and let me compile the model here with the help of model.compile. You will see that it is compiled. And verbose means what? Verbose means to see. To see. Once the training starts, it is going to show you everything which is going on. Let me show you that. See, here this is the actual training. What am I doing? See, scaled training data, and this is output data of training. So input data of training and output data of training, and epochs. What do you mean by epoch? Epoch means how many number of times actually you are going to run that particular model. You are going to pass the input to that particular model. For example, let me tell you what is epoch. Epoch is, for example, if you try to provide some data set again and again. For example, we have 100 records in our data set, and we try to provide those 100 records again and again and again. How many number of times you try to provide those 100 records? Here we are trying to provide those 100 records 150 number of times. That means we are going to train this particular model with the training data 150 number of times, so that it should, one can train it 1000 times, 10,000 times, or maybe 1 lakh times, 2 lakh times. Who knows? In real time, we need to do that if you want very accurate output. But in that case, what will happen? It will take a lot of time. That's why what I will do is I will just try to run this particular model 150 number of times. That's why epoch is equal to 150. Let me show. Now see, training has started. So how many number of times it is passing the input? 150. So see, it is showing the same thing. And now you will be able to see that it has trained the model. So it is possible because of TensorFlow. So you can see out of 150, 83, and so on. And it is showing you, see, if you people observe carefully, first time when it is trained, loss was 0.98, accuracy was only 26%. Then loss decreased, accuracy increased in second time. Then again, third time, again loss decreased, accuracy increased. Again loss decreased, accuracy increased, and so on. If I go till the end for 150, see, 150 is not a standard number. You can go and you can train the model 1000 number of times also. Finally, you will see that loss is very, very less, and accuracy is 99%, 99.79, right? Because I trained the model 150 number of times. Epochs, right? So try to understand that. Once that is done, once we have trained the model, now we can go and we can save our model. Always remember, in case of deep learning, we save the model with .h extension. So before that, let me show you the prediction. So here is the prediction. Y prediction is equal to model.predict scale underscore data. And if I go and if I try to show you the prediction in this case, Y prediction is equal to, run it, you will be able to see this prediction. But obviously, this is in numerical format, right? This is in numerical format. We are not going to make any sense out of this. But yes, our model is completely trained, okay? And as if you want to see whether the patient is affected or not affected by breast cancer, what you can do is you can go and you can make the threshold limit. So as ours is a sigmoid function, what I can do is I can actually store that particular value. So like this, what I can do is I can compare this particular value with the threshold value, that is nothing but 0.5. So you can go here and you can compare all these values with your threshold value, that is 0. What was that? 0.5, right? So go and compare that particular value to 0.5 and finally save the result of that into Y prediction variable. If I go and if I try to show you the result of Y prediction, now you can check that whether it's true or false, right? So that means Y prediction. So in the test data, first patient is not affected. Our model is saying that first patient is not affected by cancer. Second is not, third is not, fourth patient is affected by breast cancer, right? Later on, you can go and you people can actually compare the prediction data and test data. You can do that. Okay. After doing that, after getting this particular output, right? Now what you can do is if you want to evaluate your model, you might be knowing, as you people have already worked with some classification models, you might be knowing that we make use of something called as confusion matrix accuracy score to calculate or to know how our model has actually behaved, right? So I am going to just create a confusion matrix and I will explain you what is the confusion matrix. You might be knowing about true positive, true negative, and false positive and false negative. What do you mean by that? So in my case, the confusion matrix looks like this, CM. Now what do you mean by this? What is the meaning of this confusion matrix? Generally, we use this in machine learning, right? So what do you mean by this? It means, see, this is called as what? True positive. This is called as what? True negative. This is what? False positive. And this is what? False negative. So true positive, true negative, false positive, false negative. That is called as confusion matrix. So in short, what I can say is, if you add all these numbers, 52 plus 31 plus 1 plus 2, so what is this? 52 plus 30 is 82, right? So 83, 83, so 86. Out of 86 observations which we are having, our model is able to detect 52 plus 31 models, 31 observations correctly. That means out of 86, it is able to detect 83 models, 82 observations correctly. That means the accuracy is really very, very high, right? If you want to go and if you want to plot a particular confusion matrix, you can do that with the help of matplotlib or c1. So I'm going to do the same thing here, right? So here you can check, this is the confusion matrix in this case. So 52 plus 13, 52 is what? 52 is true positive, 31 is what? True negative. That means true positive means what? That means our model said that there are 52 people who are affected by breast cancer and actually they are affected by breast cancer, right? And what do you mean by 31? 31 is true negative. What do you mean by true negative? That means here our model is saying that there are 31 people who are not affected by breast cancer, and actually 31 people are there who are not affected by breast cancer. That means in both the cases our model is right. There are 2 plus 1, three cases only where our model was wrong. So it was a good data to have it, and we created a model like this, which has given us this particular accuracy, right? So if you want to calculate the accuracy score, you can go and you can calculate the accuracy score with the help of accuracy underscore score. So in our case, the accuracy is 96.51%, right? So this is how you can go and you can create a artificial neural network to identify a patient as a patient who's affected by breast cancer or not, right? That's the second example. Again, let me tell you, I'll be sharing this particular code once again. Don't worry about any documents. I'll be sharing all those things, whatever I'm discussing. Now, let's try to move to the next problem. Okay, so maybe before that, let me complete. As I told you, I will try to complete each and everything. Right? Let me show you a simple example of a deployment on cloud. Right? And after that, I will go and I will discuss the last two examples which are related to images. Just a minute. So what I will do is I will show you a simple example, simple project which I have implemented. It will take just 10 minutes. and that project I will deploy it on cloud real time, so that you people will also be able to access that project. And the same thing you apply it to your projects, whatever you will build in future, and deploy it onto cloud. So here I'll be talking about Heroku Cloud because that is free. And creating an account on Heroku Cloud, it will just take 2 minutes, less than the time which we require for creating the Gmail account. It's really easy. And in that also, if someone is having any doubt, you can always ask me, no problem. Let me show you that particular project. It is on, let me just run it. So I will be using PyCharm for that. Okay. This. Yeah. So the project is all about predicting the chance of a student to get admission in foreign university. So you know that to get admission for MS, or what you need is you need GRE score, TOEFL score. You might need statement of purpose. You might need letter of recommendation. You need your CGPA score, or maybe the university rating in which you have studied. Or sometimes they will ask you whether you have done some research or not. Right? So this kind of a data we have. From this data, what we want to do here is we want to implement such a model which is going to help you to predict the chance of a student to get the admission in foreign university for MS. This is what the problem statement is. Let everything actually load. So what is this? Whatever you people are able to see here on my screen, this is PyCharm. PyCharm is a IDE, Integrated Development Environment, and this is what we use in real time. Maybe you might have seen many people doing the projects in Jupyter itself, right? But that's not the case actually. In real time, what we need is we need some ID so that we get a model and we should be able to deploy that particular model onto cloud. Unless and until we do not deploy the model onto cloud, it is of no use, right? For example, WhatsApp. If WhatsApp would have been only on one machine, it would not have been of any use. It is on cloud, that's why everyone is able to make use of that. That's the same thing. Same thing I'm just trying to talk about here also. So what I will do is I will not go into the detailed explanation of this particular model because I hope you are aware about machine learning already. So what I will do is I will just run this particular application on my local machine, and then I will go and I will deploy it onto cloud, and I will share the link with you people, and then you also try whether it is working or not. So in this case, what you need to do is this is a PyCharm ID. You just need to check whether you are having environment or not. So in the morning you already seen what do you mean by environment. So in my case, I already created the environment. Okay, this is called as environment. I clicked on terminal and I went here. Now I will go and I will directly run this particular project here. So go to run. Don't worry, it's a simple Python program. Okay, so go here and click on run. Let me show you what this project is all about. I'm just going reverse way, you can see. I'm doing reverse engineering. This. Okay, so let me go once again here and run it. So click on this app. So it's a web application like project which we created. So it should run and it should show me one link on my local machine, which I will copy, paste it in the address bar, and I will be able to see a GUI kind of a thing, which is a HTML page. That's what we do in real time. And once I pass all the values to that, it should show me the result. That is nothing but chance of prediction of a student for an university. Okay. So it will take 1 or 2 minutes. It will load that particular link. And then once it, yeah, see, it has shown me this particular link. Now what I will do, it is restarting. Check. Yeah, now it is saying active. This is the link I was talking about. So you might be knowing, right? What do you mean by localhost? Localhost is nothing but your machine. That is actually represented by 127.0.0.1. That is the local IP. And 5000 is the port number on which by default any application runs. So what I will do is I will go here and I will try to show you this particular application. Control V and enter. So this is what the application is. Simple application. What it is accepting, it is asking us to enter GRE score, TOEFL score, university rating, statement of purpose, letter of recommendation, CGPA marks, and whether the research is done or not. Okay. So if you want, I'll be sharing this particular project also. You just need to open it in PyCharm and run. That's it. Or you use other IDs also, maybe VS Code or Spider, whatever you prefer. So GRE score is generally out of 340 marks, 340. Suppose someone has got 312 marks. TOEFL score is out of 120 marks. Suppose someone has got 101 marks. University rating is out of 5. Suppose 4 for some students. Statement of purpose. Statement of purpose, you might be knowing that those people who go for PhD, they generally have been asked for presenting their statement of purpose. So it has 5 marks. Suppose someone has got 3. Letter of recommendation, which college or HOD or principal will give or project guide will give. Suppose someone has got 4. CGPA is out of 10. Suppose some person has got it as 8 out of 10, and the research is done by that person. And now let me click on this particular button. It should show me what will be the chance of that student to get the admission in the foreign university. So for this also, we have used one data set of 500 students to train this model. That I haven't shown you. Try to understand that. My purpose of showing you this particular project here is that I want to show you how to deploy a model onto cloud. That's why I'm showing you this particular thing. Otherwise, there is no point. Okay. But still, someone wants to understand that. If you want to understand that, definitely, always you can you try to run it. See, my output is your chance for prediction is 6%. This is how it actually runs on local machine. But I want you people to access my project. What I will do, what I need to do for that, I should be deploying this particular application onto cloud. So let me stop it here first. Now what I will do is I will go to the folder where app.py file is there. The .py means Python file. Wherever my Python file resides, I will go to that particular path. I will copy that path. So let me just select everything, Control A, Control C, and first step, try to understand those who are interested to deploy their application, maybe machine learning applications or maybe deep learning applications. If you want to deploy your applications onto cloud, you need to follow the same steps for Heroku Cloud. And somewhat similar for other clouds also, like Amazon Web Services, Microsoft Azure, Pivotal, Google Platform, and so many others. So copy this particular path wherever your .py file resides. Once you copy that path, go to your command prompt. Okay, so I am already in the command prompt. Type cd, paste that path, enter. That means I am saying that just go inside that path, right? So I am now in that path where my .py file actually resides. Currently, I am in that path, right? Now, after that one, once I am in this path, as I want to deploy this particular application onto Heroku, first of all, I need to log into Heroku. So I will type Heroku login and enter. So what it will do is, it will take me to Heroku's login page. It will open the browser and it will take me to the Heroku's login page. And it will ask me to click on login button. You people will also be able to do the same thing. It is just that you need to have an account on Heroku. You just Google, create Heroku account. You will get it. So this is what I was talking about. This is one of the cloud platforms which is available, which is free. So just click on login button. It will show me logged in. Once it shows me logged in, I will again go to the terminal and I will check. I will check whether I am logged in or not. Now see, it is saying that I am logged in as Yogesh PM5555@gmail.com. This is my personal email. Once I am logged in, second step is Heroku actually makes use of something called as Git. Many of you might be knowing that Git is a repository which you can make use of. So it is saying that no changes added to commit. Right? There is on branch master, everything is clean. So I just fire that command. I should have fired that command later on also, but yes, you can fire it right now. Not compulsory. Next step is initialize the Git. To start with, you need to initialize Git repository. Okay. So or before that, before initializing, let me just scroll down. Before initializing the Git repository, the first command was what? The first command was Heroku login. After Heroku login, before initializing Git repository, what I should do is I should try to create the application. This is the command Heroku create. Suppose I want to create application with the name FDP, maybe 1234. This is the name of the application. Suppose FDP 1234. Heroku create name of the application and press enter. This is the second command actually, which is going to help me to create the application. If that name is available, it will not show me any error. So in this case, this name is available. That is the second step. Now the third step is to initialize the Git. What is Git? Git is a repository. Many of you might be using that, right? Many people, what they do is they put their project work on Git repository. So what I'm doing is I'm just initializing that Git repository. I'm just starting that Git repository. You will also be able to do all these things once you have an account, which is free. So once I initialize Git repository, now you can go and you can fire status command once again. It is just going to show the status. So on branch master, it is saying no changes added. That means we haven't committed anything till now. Okay. After that, git status. Now there is a command which is git space add space stop. What this command is going to do is single darkness current directory. So whatever is there in the current directory, we want to add it onto git repository. Right? That means git space add space dot is going to add everything from the current directory onto git repository. And just you need to do what? You just need to press enter. Once you press enter, everything will be added. Whatever is required for that project will be added onto Git repository. Once that is added, next command is commit. Git space commit space -am, and you need to give some string. Suppose hello in single quote or double quote. You just need to type some name. Git space commit space -am hello. This is the command to commit everything whatever we have done till now, and press enter. Okay, so it is saying that one file changed, right? Something is committed. Now, last command is if everything is okay, last command will be to push your application from Git to cloud. The command is git push Heroku master. This is the last command. If everything is right, it is going to push our application onto cloud. Let me check. So remember, our name is what? FDP 1234, right? But it is saying that no such application as SKN 2009. So this particular application I created for some another session. So it is actually trying to detect some other name. It is not detecting my application's name. So I need to tell cloud that that is not my application. My application is something different. So for that, the command is this one. So it is Heroku git remote space -a, and the name of our application is FDP1234. If you people remember, this is what the name I have given to my application, FDP1234. So this command is doing what? This command is telling that the name of my application is not SKN 2009. The name of my application is FDP1234. Let me press it. Now it should set the Git repository to that. So it is setting that Git repository to our application. Now what I will do after this? Now, after that, I will again go and try to push my application onto cloud. So git push Heroku master. Let's see. Now it has started deploying my application onto cloud. So it has detected the application as a web application. It has detected the application as Python application. So the steps of deploying any application onto cloud, you will get in this particular project actually, whatever I am trying to show, because the same project I talked just now. There you will get all the necessary files to deploy any application onto cloud. For Heroku cloud I am talking about. If you want to do it for AWS, actually you need to provide credit card details for that. For all the other clouds, you need to provide credit card and debit card details. That's why I did not show you the deployment of the project onto all those clouds. Right here on Heroku, you don't have to provide any details of credit card, any banking details. You just go create the account, give your mobile number, your email ID, and that's it. You can actually go and you can use it for 2 years for free. And at a time, you can deploy 5 applications. If you want to deploy more than 5 applications, what you can do is just go and delete the previous application. Now see, in my case, this particular application is deployed successfully. Now if I want to show you, if you people want to access my application, what you do is you copy this particular link. See, it has given me one link. So I will just copy that link and I will send it in the chat box. You people just let me know whether it is working in your case or not. Just copy the link which I will be sending you, hit that link in the address bar and let me know whether it is working in your case or not. Just let me know yes or no. It should work in everyone's case. You should be able to see the graphical user interface. So all of you please go and copy that link paste it in the address bar and let me know whether you are also able to see same thing, right? GRE score, total score, and all those things. Yes or no? Just let me know whether it is working in your case or not. In everyone's case, it should work actually. Yes, many of you are saying that yes, it's working. So you people can go and you can use that particular application, right? So that is how you can deploy any application onto cloud. I know that if it is something new for you people, if you haven't tried it out earlier, you might need to revise the things, whatever I'm trying to tell you here, and you will get everything. This is not that much hard. Okay, just 6 to 7 commands for deploying your application onto cloud. That's it. Now, moving to the remaining part. Let me go and try to show you the remaining two examples which I was talking about. That is nothing but image data, right? So let me talk about that. First example. The first was about what? First was about identification of cat and dog. So what I have done here is I have created what you can say CNN, convolutional neural network I have created, right? So this particular data set I have already shown you, cat and dog, right? So the program which is related to that one is this. So I am not going to write down this particular program from the start itself. I am just going to show you execution and the flow of that, right? So again, this file also you will get. Whatever the steps you require, all the steps are also shown. The most important step is that TensorFlow should work in everyone's case. Otherwise, you will not be able to do all the things whatever I am telling you. That's why first thing only I shown you that thing as first thing, right? Initially, I have shown you the same thing. Now, let me go to the folder where my data set is there. Okay, so this is the folder my data set is. So I have shown you the data set of cat and dog. If you check, the data set for cat and dog is divided like this. One folder is there which is C880 and another folder is there which is DOGG. Right. Inside C880, if you go, you will be able to see the images of cat like this. And inside dog, if you go here, you will be able to see the images of dog like this. Now, first of all, what we will do is we will try to train our model on the basis of all the images of cats and dogs. Okay, and then what I will do, I will download one new image from the internet and I will try to pass that particular image as input to this particular model, and then we will see whether our model uses the correct output or not. Let me start it. See, first step is what? We are actually importing all these methods. So try to understand whatever the models we have seen till now. Simple neural network and artificial neural network, right? ANN. In that case, you are having input layer, hidden layer, and output layer. But in case of CNN, which is mostly used for image data, you will be having more layers. For example, you will be having input layer, convolutional layer, pulling layer, and flattening layer. Okay, and then your final output. So convolution and pulling, these are the two extra layers we will be having. Other thing is same, because whatever the output we get from CNN model, that output will be passed as an input to ANN model, and then we are going to get the final output. First of all, let me run everything. Okay, I will see all these steps, whatever you are able to see. What are these? These are just import statements. That's it, nothing else. Okay, so I will just run it. So it is running. You can see there is a star here. Now it has imported everything in my case, right? I am not getting any error in this case because TensorFlow is correctly installed in my case, right? Now let me create a sequential classifier, initializing the convolutional neural network. So we initialize it the same way what we have done in case of artificial neural network. Let me run it. That is done. Then first step. What is the first step? We need to create a convolutional layer, right? So how to create the convolution layer? So I am using the activation function called as ReLU. I talked about ReLU if you people remember at the start, right? Rectified linear unit. It is one of the activation functions which can be used. So I will run this particular thing. After that, there is another layer which is called as pulling. So for that method, for that actually we use something called as max pull 2-dimensional. Use this particular method, and I will run this one. Okay. Once pulling is done, convolution and pulling is done, and you can repeat convolution and pulling as many number of times as you want. See here, what are we doing? We are adding a second convolutional layer. See, second convolutional layer and second pulling layer we are actually adding here. So I will run it once again, and then the final layer is going to be flattening layer. So we are just trying to flatten the data or ravel the data. Okay. So those who are aware about NumPy in detail, they will understand whatever I am trying to talk about here. See, everything is actually based on NumPy. I cannot go actually in detail and explain you the architecture of convolutional neural network here because it will take some more time. Right? That's why I'm just trying to give you overview at least what happens in case of convolutional neural network. So now full connection, I will go and I will use activation function once again. And finally, I will be using sigmoid function. Right? And now here the compiling of the model, you can say. We are going to compile the convolutional neural network here. So let me run it once again. Right? And now next step is fitting the CNN to the images. So whatever the images I have shown you, dog and cat images, right? So we are using some package that is called as image data generator, which is present in what? TensorFlow.keras.preprocessing.image. From that, I'm just importing this particular package or method, and here I'm trying to scale my data according to or the images according to the problem statement, right? So I'm just trying to scale it because we have two classes. Now after that, here we are trying to rescale it. We are generating a test data here. So we are generating test data here, and here training set and testing set we are trying to create from what? See user desktop today. This is the folder actually. So in my case, the folder name is here. This is the folder where I have cat images and dog images. So what I'm doing is cat images and dog images. I'm just trying to divide them into training set and testing set. So let me check the path first. See user desktop today DL. Let me just confirm the path. See desktop today DL cat dog. Okay. So here you can check it is cat dog. So I will have to give the path in this particular folder cat dog. Let me check it. So yes, the path is right. I am in the correct path. So what am I doing is I'm just trying to divide the data as training set and testing set and running it. Okay, so you can see it has found that 277 images belong into two classes. Here also 277 images belong into two classes. And once that is done, once we have divided that particular data into training set and testing set, now the actual training is going to start according to convolutional neural network. So what I have done is earlier actually I tried to train this particular model with 8,000 number of epochs, but it was taking a lot of time, near about 12, I think 12 to 13 hours. So what I have done is I just reduced it to 800. So might be our accuracy might not be that much good, but there is some limitation here. I want to show you the output also. That's why I have taken the number of epochs. That is how many number of times you should train, take the action, teach that particular model again and again. So I am teaching that particular model again and again with the image data 800 number of times. Okay, it is actually step. It is actually step. So in one epoch, I am teaching it 800 number of times. Epoch is one. If you want more accuracy, you can go and you can even increase the number of epochs. In real time, you will see people are using the values of epochs in lakhs, 1 lakh, 2 lakh, and so on. So this is the actual training. Let me run it. So the training should start now. Now see, it has started. So if you people are able to see this particular thing, right? See, just check it. Out of 814 number of steps, only one epoch. As there is only one epoch, that means we are trying to pass the data only one time, but repeating the things steps 800 number of times. So only one epoch, but number of steps per epoch are 800. So just try to see the loss and accuracy. Loss, it should decrease, and accuracy, it should increase, both for training as well as testing. So just observe, it will take some time to train the model in this case. So till it will complete all the 800 steps, it will go on running. This is what the training is. In real time, that's why you might have heard many people saying that the models which we create with the help of image data, many times those kind of models actually they take a lot of time to train. So it is because of that one. Because see, even if you take an example of human brain, or just take an example of a child, right? When it is developing, child also takes a lot of time to learn the things. He or she learn the things step by step only, right? So for example, if you are trying to show something to a child, if you are showing him or her a bat, he doesn't know what bat looks like. But if you show him the pictures of bat, original bat, and you try to show it him again and again, step by step he will learn. Same thing actually happens in this case, right? Same thing is going to happen in this case also. So from the image data, we are trying to train our model. So you can check now the loss is decreasing. It is decreasing and accuracy is increasing. So this is what the training is going on. Once it is complete, you might see some high accuracy. Might not be that much high, but let's see how much accuracy we will get. Because I have some limitations here, that's why I have put it as 800. Because otherwise it was 8,000 earlier. I just removed 10. Okay, and let me show you the final output there. Once training is done, I will just download one image. So let me download one image right now here. So what I will do is I will go here, I will Google one of the image, maybe just take an image of a dog for example, right? And just pass that particular image as an input. Let's take any image. Let's take this particular. I will download this particular image, and we are going to pass this image as input to our data. We take this one. So save image. Okay, so I am going to save image with the name FDP. Okay, so in the same folder, in DL folder, I am going to save it with the name FDP and save it. So I will be passing that FDP image, which is the image of a dog, as input to our model. Let's see whether our model will be able to identify it correctly or not. It should identify it as a dog, right? So see, loss is decreasing, accuracy is increasing. Accuracy is now 81%. So it will go on till 800. I think we are near about 500, right? So it will take 2 minutes, 2 to 3 minutes, and then it will be done. So I will recommend that once you get all these things, at least go and try to execute as per whatever I told you. Just go and try to execute at least, and then in whatever you want to refer, if you want to refer some book or some material, whatever you want, you go and you refer those things. Definitely, one thing is for sure that these things definitely will help you to understand those things, or at least help you to make those things easier to understand. Right? That's what you will notice in this case. So okay, till more than 600 steps are done out of 800. So see, what is this? This is elapsed time. So it has taken 1 minute. Oh, sorry, 1 minute not taken. This much of time is remaining. So I think it was 2 or 3 minutes it has shown earlier. So it also calculates how much time you are going to require to train a particular model. So I told you that when I made this particular thing at 8,000, it was showing me near about 12 to 13 hours. Yes, you just can imagine what will happen if I go and if I try to increase the number of talks. It will take a lot of time. In real time, you will see that it takes 2 to 3 days to train a model, because in real time, model should be really good, right? And specifically talking about healthcare domain, accuracy is at most importance. You cannot say that if a person is not affected by COVID-19, and if you are saying that he is affected by COVID-19, that's a big problem. And even if you say that some person is affected and you are not, your model is saying that not affected, again it's a big problem. The accuracy in case of healthcare domain is at most importance. So see, 799 steps are done. Only one step is remaining, so it will be done in few seconds. So you can check final accuracy is near about 88%. But yes, still there is loss, 0.20. So once this is done, once this star is gone, I will go and I will try to pass that particular image as input. So that particular image is in this part. So I will just change the part DL. And what was the name of the image? FDP. So I will give the name of the image as FDP. It should identify it as a dog, right? Because that's an image of a dog. Now I'm ready with my inputs. User, same path is there. In the same path, I actually this image fdp.jpg. Let me once again cross check. So in DL, there is the image as, yeah, FDP is in smaller things. So let me go. Okay, it's still waiting. It's still showing me 799. Let's wait for some more time. So fdp.jpg is the image of a dog. Our model should be able to identify it as a dog. Let's see. And in the next example, it will take more time than this, because the X-ray images which I am going to show, right, the number of the X-ray images is also very high in that case. I think in this case it was only 200 or 300 images, but in case of COVID-19 data, I think the images are more than 1,000. So obviously, it's going to take more time in that particular case. So one thing is for sure, that those who want to learn about deep learning, right? So obviously, patience is very important. Okay, okay, this taking some time. Maybe till then, if you people have any question, you can ask. Because after this, I'm just going to display last that particular application, last demo, which will be about COVID-19. So if anyone is having any doubt, uh, it will be done for sure.
If
Sure.
anyone has any doubt, you can ask or you can put it into the chat box.
Yeah, sure. Hello. If someone has asked me some doubt, voice was breaking. Yeah, I think you people are not, if you are not able to unmute yourself. Yes, thank you, Mayura. Yes, yes, please. Anyone, any question? Because it is still training. Let it complete. So we have some time if this training is going on. This model training is going on. Till then, you can ask questions or whatever you question.
Sir, there is one question. What are the factors for deciding for steps
Steps
per
per
epoch?
epoch. Okay. So Devendra Apse sir has asked that question. So what I will suggest Devendra Apse sir is, it all depends on how much accuracy you want. It depends on the data set. It depends on the problem statement, and specifically it depends on the domain in which you work. As I told you, in case of healthcare data, we want the accuracy is at most important, right? So in that case, number of epochs should be as high as possible. So how are you going to decide about number of epochs? You need to train the model again and again and see whether you are getting that what you can say, the accuracy which you do that. So it depends on number of factors, specifically on domain and data set. I hope it's clear, Devendra Singh. Right. Pragati madam has asked best site to refer.
Sir, second question is which is best?
Best site to refer. So, Pragati madam, best site to refer, I can say you have a lot of sites for data sets. So, I will recommend to refer some GitHubs, because GitHubs is going to show you some projects. Plus, you have other things like Kaggle, right? Kaggle you have for data sets, and Kaggle actually arranges different what we can say, different what we call it as, they are in different programs where you need to participate and you can actually solve your problem statements. And plus more, I will suggest, if you really want, I have in my case, I have already created. If people are interested, if you are asking me about referring, just go here, search Yogesh Murumkar, and just search for machine learning or deep learning. Right, you will get some projects, some models, algorithms, some sessions which I have conducted, and this is also something good you can refer if you really want to understand. Right, so this is what I generally, whatever I do, some projects I try to upload in on YouTube also. So this is my YouTube channel. This also you can. I hope it's clear, madam. Right? And anyway, I have given you some links. What I will do is I will share some books. Okay. So uh, maybe PDF books I will refer. There is one book for TensorFlow only. I will share that, which is written by a person who is a mechanical engineer. Just try to understand. Okay, let me go through some of the questions. Okay, I will go through the remaining questions later on.
Mhm.
Let me see what our
Sir,
model is saying. Yes, sir. Yeah, it is trained. All of you see, it is trained. Yes, sir. Anything?
sir, actually, I have one question.
Yes, sir.
No, sir, I'll ask at the end. No problem, sir.
Okay, no
We
problem, sir.
can
No
proceed.
problem. Yeah. So, see, now you people can see that 800 out of 800 steps are done. And in this case, let me just move this. Now, in this case, you can see the final accuracy here is 88, right? And validation accuracy final, which is 99.64%. That is somewhat good. Now, what I will do is, I will try to provide this FDP image, right? I told you it's a dog image. I think it was a dog only, right? So I'm going to provide this particular thing as an input to our model, and let's see whether it provides us the correct output or not. So initially, before starting your session, I already tried out all these things because many times what happens is because of some silly things we make mistakes. That's why you are able to see this output. But let me run it. Now see, it has shown me the output as well, right? So that means it has correctly detected this particular image as an image of a dog. If you want, I can go download one more image, maybe of a cat, and I can show you that my model will be in a position to identify that particular image as a cat, right? So let me just open this particular image once again. See, it was a dog, and our model has correctly identified that particular image as dog. So this is a simple Python code if else thing we have written, right? So that's how actually you can go and you can train your model based on the image data, right? Let me fast go through the last model and then we will come to the questions. So I think many people are asking questions. So let me just show you the last model itself. See what I will do. Here is that. Yeah, so COVID-19 detection. But see, in this case, it will take some time. But what I will recommend you people is you please go and you train the model because for training it will take some time, and for what you can say evaluating this model it will take time. So I will go and run each and everything. So run it, import numpy and import matplotlib, import tensorflow as keras. This particular thing I am executing second line. After that, from tensorflow I am importing everything. From TensorFlow, I am importing image, this one I am running, and this is the convolutional neural network model. Whatever you are able to see, whatever I selected. What is this? I told you, convolution layer, pooling layer, convolution layer, pooling layer, convolution layer, pooling layer, and finally flatten layer. So in case of the convolution neural network, we use convolution and pooling layer also. Right? So I will run it. Once that is done, I will show you summary of the data. So this is what the summary of our model which we created here, right? Architecture you can see. And now what I will do is the data which I have shown you in the morning, which were the X-ray images, right? I will try to make use of that data. So that data I have actually stored in this particular part in my case. So what I will do is I will use a class mode as a binary, right? Because it is again positive patient or not positive patient or negative patient, right? So I will go here. Now you can see it has detected 1,824 images belonging to two classes. So this was a training data, and validation data is also there, which is also having huge images, huge number of images. Again, greater than 1,000 images. So again, 18224. And now I will go and I will train the model. Okay, so see, in this case, what I have done is number of epochs are 10 and steps per epoch is 7, right? So it is going to calculate out of 10 first epoch, and in the first epoch out of 7 first step, and the accuracy is 75% and loss is 85 87 something, right? And see, so it is going to take some time. I will tell you it will take near about 8 to 10 minutes to complete this training. Okay, till then now I will go and I will move to the questions. So let me check what people are saying. So we have some 5 to 10 minutes. Let me see. Okay, some questions if I have missed. Okay, what are the factors deciding for stage for epoch done? Base site to refer can be deployed on any cloud? Yes, sir. Someone Redmi named as Redmi is asking, can we deploy on any cloud? Yes, you can. You have different options. Heroku I have shown you. You have AWS, Pivotal, Microsoft Azure, Google Cloud Platform. But one point I told you that the clouds other than the Heroku cloud, they are going to ask you to enter all the details about your banking, credit card or debit card, maybe. Okay, and they are available for only for 1 year. And before using AWS, be sure that you are going to discontinue that particular account. Otherwise, they will charge. Redmi, I hope it's clear. Okay. Is it true epoch work like for loop? What is that? Is it true epoch work like a yes, to some extent, Devanand Mishra, you can say because loop is also something we are repeating again and again, right? To some extent, you can say epoch is like a loop because we are actually asking it the same thing again and again, right? Yes, so to some extent, it's right. Can we use ANN to build recommendation system? You can use, but not recommended because we have RNN, which is going to give you very much better results as compared to ANN. I think Mansi Pandrekar madam, right? I think it's clear. I will recommend using RNN for recommendation engines, recommendation systems, not ANN. I hope it's clear. Okay, thank you, Redmi, thank you, Pragati Pinage madam, Devendra Apse sir. Andrew NG YouTube series is also good thing. Yes, that is also good. You can go and you can follow for better understanding. That is also good, right? There are a lot of resources which are available on internet. That's for sure. Yes, right, Devendra Apse sir. Okay, thank you, Mahendra sir. Okay. 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 I think I answered all the questions. Yeah. Implementation of
Sir,
devices.
sorry to interrupt,
Yeah.
sir.
Yes, sir.
Hello.
Yes, yes, sir.
Sir, I have one question.
Yes, sir.
Which approach in deep learning we should follow to implement intrusion detection system, sir? ANN, CNN, or RNN, or mixture hybrid? What would be the better one?
So intrusion, you are saying in which case in computers? Hello, sir.
Yes, sir. Yes, network intrusion.
Right. So in that case,
Yes, sir, yes. My voice is audible, sir.
but it's breaking actually in between. It's somewhat breaking.
Yes, sir. Yes.
So I got your question,
Network
sir.
is unstable.
Yeah. So see, in that case, sir, even if you go with simple ANN, that will do. But because at the end you are not having images kind of things there, right? You will be having numbers and text. You
Yes,
can go
yes,
with
yes.
you can go with
Text,
ANN.
text data.
Yes,
Yes.
yes, ANN.
Thank you so much, sir. Thank you
Yes, sir.
so much.
Thank you.
Thank you so much. Yes, sir. Thank
Okay. Thank you, Nilesh Pinjarkar sir. Thank you, Bolne sir.
you.
And see, all of you, just try to notice that my model is still training.
You
It
can
will take
ask.
some time. Sir, your voice is breaking.
Hello. If anyone has a question, you can ask. We have a time now.
Yes, yes. So I am at the sixth epoch now out of 10. And from the sixth epoch, the step number which is going on is second. You can check it. Fourth step. Okay, we got accuracy 72%. Sometimes it is increasing, sometimes it is decreasing. Here the accuracy which is the current accuracy, it is 72% it is showing. Okay. Again I am at epoch number 7 out of 10. See, again whatever the number of epochs and whatever the number of steps you are able to see, again that will not be enough for this much of data. Let me tell you. Maybe you might not get a good accuracy in case of COVID-19 data set. And in this particular problem because data actually I should be using a very base data, but I just tried to search for the data and I got this one. So I just use that. So it is near about 1 GB, more than 1 GB of data. if you talk about all the X-ray images for COVID patients. And there are a lot of other data sets also available. If you just, even if you go and if you try to use the code which I'll be sharing, even if you try to use this code with other X-ray images, you will be able to create the model. But make sure that TensorFlow library should be working right in your case. Otherwise, you will not be you will not be able to create the model. Right? So again, number of epochs, two epochs are remaining. We are at the epoch number 8. So you people can see the accuracy. Okay, it is showing me the accuracy at 90% right now, but it is decreasing, 87. Sometimes increasing, sometimes decreasing. That might be a problem. Let's see. Okay, 6th number step. Now 7 out of 7 steps are completed from the epoch number 8. Now it has moved to epoch number 9. There is only one delay. So you can check for each epoch how much time it is taking. 56 seconds. So near about 1 minute it is taking for each and every epoch. That's why I said 10 minutes you will require for training this model, and some 5 to 6 more minutes for evaluating the model as well. Evaluation we will do on the basis of training as well as testing. So see, that's to some extent. That's why Devendra Mishram, so that's why I said to some extent you can say epoch will work. See, for loop is like what? Let me share my screen. See, obviously there is a difference between for loop and epoch. Otherwise you would have used the for loop only. See, Devendra sir, for loop is going to do what? For some variable I in range, right? In range. Suppose maybe if you are giving the range as 100. So what it will do? It will do it for value of I as 1, 2, 3, 4, 5, and so on. And it is going to repeat all these things again and again. What epoch is doing is epoch is actually trying to talk about some data, and that data it is providing again and again. It is providing same input again and again. Try to understand that. That's why I said to some extent you can say it is similar to for loop, but it is not exactly like a for loop. Otherwise, you would have used the for loop only instead of using those kind of methods for epoch. That's why I said to some extent. You can say, is it making sense, Devendra Mishra sir? Is it clear? Try to understand. We actually try to provide the same data again and again in that case. Same images. Yeah, it is a post exercise consumption. What do you mean by that? Yeah. Okay. So see, training is done. Now our model is trained. You can check all the number of epochs which we tried, 10 out of 10 done, and all the steps are done. So you can see loss is 63%, accuracy is only 80%. Then validation accuracy just 60%. That means there are going to be problem. Right? So let me go and try to run this summary. Summary is going to show you each and everything in detail. What is the loss, and what is the accuracy, validation loss, validation accuracy, training loss, and this is how we save the model. This is how we can save a model in deep learning. Always remember, in machine learning, you people might have used .pickle or .sav, but here we use .h5, and this .h5 file, kind of a file, you people can go and you can use in IDEs like PyCharm, right? So remember, that's the difference between deep learning and machine learning. In machine learning, what we do is .pickle and .sav, but in deep learning, it is .h5. So I will run this, and now if I go to my working directory, you will be able to see the model with the name model1.h5. See, this file is saved in today's date, 9th of October, and this is the time, right? So that is done, model is set. Now this evaluation, I will go and I will just try to evaluate the model. Model.evaluate underscore generator. What it will do, we are trying to evaluate a model based on this train underscore generator, whatever we created earlier. So what will happen in this case? Again, it will take 6 to 7 minutes, train generator. So it will show me the accuracy and the loss like this. It will show me accuracy. So previously also I got a loss. This is the loss and this is the accuracy, right? So this will be for training data and this will be for validation generator. So I am going to evaluate it, right? And finally, what I am going to do is see, it will take some time. this case, you can see there is a star here, it is running. What will happen? We will try to evaluate this particular thing. It will show me the accuracy and the loss, and then once everything is done, right? So I will check. Zero means COVID and one means normal patient. Okay, normal person who is not affected by COVID. And here we will create some empty lists, y actual and y test. And after that, we are going to provide the data of the positive patients and the negative patients to the model. And then it is going to give us y actual and y test. And then we are going to compare that. And finally, we are going to get a confusion matrix. So in my case, you can see that earlier what I got is my model is able to detect only 497 patients correctly out of this many number of patients. That means accuracy is less. I need to train more. But if I try to increase the number of epochs and number of steps, it will take a lot of time in that case. That's why what I will recommend is once you get this particular code, what I will recommend is you go and you try to execute this particular code and try to see what happens. If you have any doubt later on, definitely I will be there. If someone is interested, if someone is working on some projects might be, I will share my WhatsApp number also. You can actually share your queries. No problem. I will be there. So my WhatsApp number is this one 965 70 80 95. Or otherwise you can email me if you have any doubt. My email ID is this one Yogesh PN 5555 at the rate gmail.com. Yeah, at the rate gmail.com. So I know that many people, many times I found out that in many trainings, many people are interested to develop some models and to train some models. So that's why I'm always there, no problem. You can just share your queries. You can just send the screenshots also, no problem. This is my WhatsApp number and this is my email ID. You can always connect. Okay. So it will take some time. Again, whatever I wanted to tell you, this is the thing actually. Exactly the same thing, whatever I had shown you in the previous model. It is just that the data is changed. Otherwise, one understands.
Anyone has doubt, you can
Yes.
ask because we got a time now.
Yes, I'm going data right now. You can ask. And I think people are leaving. Some of them they are leaving. Yes, anyone any doubt? Okay, I think sir they do not have any doubt. So
We have clear with the doubts.
yes, maybe they might be having doubts later on. So I will share this.
Uh,
This detail.
yes.
You people can
Yes, sir.
always
If
come.
any doubt comes to me, I'll send you the
Yes,
email
yes,
or
yes.
I'll send the message.
Swati Jadhav madam. CNN or RNN you can try out for that. Biometric. CNN or RNN you can try it as images are there. For your problem, I will, yeah, yeah. Thank you. Okay, sir. I think everyone is done with the doubts.
Okay, sir. So with your permission, may I conclude?
Yes, yes, no problems.
Okay. Thank you so much, sir.
Thank you, sir. Thank you all of you.
Yes, very, sir, wait, sir. Very good evening to one and all. I would like to take this opportunity to thank Mr. Yogesh Murumkar, sir, on behalf of Computer Department and Head of Department, Dr. P.N. Mahalle, sir. Srimati Kashibai Navle, College of Engineering, Pune. Sir have delivered a very nice and informative session on deep learning. Sir has bridged the gap between AI, ML, and TL. Sir has also explained the different approaches of deep learning, that is ANN, CNN, and RNN. Sir has also explained with a very easy to understand language different case studies like prediction of cat or dog, cancer prediction, as well as COVID detection. Sir has also explained how to upload the model to the cloud. I'm very much thankful to the sir because he has accepted our invitation for the 2 consecutive sessions. We all found this session extremely useful, sir, and very informative. I once again thank you, sir, for sharing your valuable knowledge as well as providing your precious time to all of us. Thank you so much, sir.
Thank you, Tambul sir. So
Sir, with your permission, may I end up the meeting?
yes, sure, sir, no problem.
Sir, once again, thank you so much, sir.
Yeah, thank you all of you.
Bye bye.
Bye.
Thank you, everyone. Bye bye. Take care.